Hello, everyone, and welcome to this new session, new module, Python programming. I'm Dr. Swapnija, and in this module, we explore the very most essential tool in modern bioinformatics, that is Python programming. Okay, so if you are in this field of bioinformatics, Python is very essential that you cannot ignore. So, like when you want to analyze genomic data, uh, or working with any protein structure, any automatic task, any research project. So Python provides very important tool which is required for analyzing. Okay, so before moving towards actual hands-on, let me share screen. Just let me know. Screen is visible. Yes, can anybody please tell me?
No, ma'am.
It's not visible. Just let me share. I hope it's visible now. Yep.
Yes, ma'am.
Okay. So first of all, let's do a quick round of introduction. Like already I took your R programming, if you remember, but some new enrollment I can see here. So please share your name, your qualification or educational background. So I'll get an idea. Or you just tell me how many of you are having a prior experience with Python. You can just text in chat box. Or if any other programming language, not specifically Python, or you already use this programming in your research project, or if like any specific topic, any specific skill, like you are interested in learning throughout this Python module, any particular requirement. Yeah. All are new to Python.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, fine. So from installation we'll start like from scratch. Fine. So first, before doing hands-on or actual implementation, let's just understand why we are using or why it is required in biological application, this Python. Okay. Just cooperate as due to some health issue, uh, some problem I'll face. So first we'll see the actual application of this programming, why we are using. So data analysis and processing. Analysis means when we use Python, there are many libraries are available like pandas, numpy. We will explore these all libraries later in detail, but these libraries are very important, like to analyze the data manipulation, या फिर analysis, any statistical operation we can perform very easily with libraries which are exist in Python. Like suppose we are cleaning genomic data or transforming or just exploring data set, online data set like NCBI and all these things we can do. Okay. So next, algorithm development, like when we want to the main important thing, Python is the choice for writing algorithm because Python's clear syntax as compared to other programming language. It is very clear, very expressive and easy to understand for new users. It's not like only programmers or computational background students can understand this. Anyone can understand the syntax, so it's ideal choice for writing algorithm, prototyping, implementing algorithm. Algorithm means what? Like simply take example of sorting, searching, or just complex algorithm, like any specific task or any like program oriented, experimental oriented algorithm if you want to write. Then automation. So automation means, like, suppose any task, if you want to do multiple times, or repetition, we can say a repetitive task, or just like a complex algorithm or complex workflow. So Python script is very easy to automate this process, so it will save the time and also reduce the errors. That's why automation is important, and for automation Python is the best choice. Visualization. In Python, there are multiple libraries are present, like Matplotlib, Seaborn. So these libraries enables creation of visualization, or insightful visualization, we can say, like some charts we can develop, graphs, or any interactive plots. Okay, so for represent our data, for represent our results, visualization is important to analyze the output. So, and the visualization is very easy with help of this libraries, present libraries. Then machine learning. So machine learning, Python emerged as a dominant language, we can say, in machine learning, because there are libraries like scikit-learn is there, then tensorflow is there. So these libraries provides a tool for implementing such kind of algorithms, machine learning algorithms, or any traditional models to deep learning models. And for that, there is one more important thing, that is custom tool development. Custom means, because versatile nature of this Python language, we can create custom tools. Custom is like specific requirement, as like bioinformatics students, suppose we want to develop any tool which is specifically for our experimental project, or any project which we are handling, so we can create that tool. Even we can integrate multiple libraries in one environment, suppose statistical analysis along with sequence analysis. So these two libraries we can incorporate in one environment, so it is easy to develop tool and align whatever your unique requirements. So for example, with perspective, as a bioinformatics students, let's take example, like suppose you want to perform sequence alignment, or sequence means any kind of sequence like DNA, RNA, protein alignment, or assembly, or just example of annotation, anything we can perform. Or genomic data processing, simply we can take a raw data of like NGS data, even protein structure prediction. Then suppose we want to develop any bioinformatic tools, so with help of existing softwares, existing libraries, we can incorporate this and create a tool. Visualization, even for you have suppose raw data, gene expression data, so statistical analysis we can perform, so statistical test and analysis for this data set. And with help of library like biopython, we can use on, or we can fetch online databases like ncbi entries, all these things, sorting, retrieving, even managing all this data in that database is possible with these all libraries. So database management also possible with this programming, Python programming. Okay, then Python for bioinformatics, how we can use Python, as we already discussed few points, but due to versatile nature and general purpose nature of Python, means we can use or we can apply wide range of tasks for algorithm or analysis, any kind of work we can do because of this versatile nature. Ecosystem means, like, there are multiple libraries are available, multiple modules are available, inside that module multiple classes are there, so that all things we can use, widely use for bioinformatic application. Like suppose we just want to work with numerical data, so numpy is there. For files like excel files, csv files, so pandas libraries are there. So there are multiple libraries, and from that libraries there are multiple functions we can apply for biological data manipulation, biological data analysis. Then community support. So community support means what? Like large communities available or exist, and that is active community. Means what? Means like suppose you want to take example, you want to learn something. So there is a wealth of resources available, wealth of tutorials are available, and even there are multiple forums which are available for problem solving, and also they provide their learning material. So that's why community support is great for Python language. Ease of learning, because of its clear syntax, its readable syntax, we can use this, and even beginners can learn this. Okay, as itself bioinformatic is a multidisciplinary field, right? Means there are many what we can say multiple streams are there: physics, biology, chemistry, zoology. So researchers from diverse background, and they don't have experience, programming experience, still they can adapt this language. Integration with bioinformatic tools. So different tools, specifically bioinformatic tools and databases, which provides API. API is what? Application Programming Interface, or you can say libraries in Python. So we can integrate for analysis of any workflow. Then data analysis and visualization. So, analysis means like there are multiple libraries as we discussed, pandas, numpy. So, for analysis, we can use this. For visualization, like matplotlib is very important library which is used for visualization, and it also incorporate with databases, large databases. Like suppose you have a genomic data, experimental data, so that data we can fetch and then we can use libraries for visualization purpose. Automation means like any repetitive task we can perform, like multiple files we want to execute, or just want to run analysis or analyze any file with multiple parameters or multiple time period. So there's no need to write again and again same script. Better we can automate the task. So by automating we can save the time and also reduce the error. Some bioinformatics specific libraries. The best example is BioPython, which is dedicated library for bioinformatic application. Means what? Like biological computation, or simply if we want to handle sequence like FASTA files, or gene expression data like numerical data, CSV files, even the VCF files and all these things we can handle by using BioPython library. Interdisciplinary collaboration, as we right now discuss, like collaboration with researchers, those from diverse field or diverse background. So Python's popularity makes it as a common language, so easily shared, easily understood across different domains, different platforms. The main important thing that is open source and free. As Python is open source and freely available, no need to pay or license charges. And this is the main thing, like encourage the collaboration. And due to open source nature, means we can adapt new libraries, adapt new tools, and these are continuously evolving, continuously improving, means updated version we are getting. So these are some important things, like why we need to learn Python. And definitely this empowers the bioinformaticians, like a different tool set we can handle, even collaboration and computational analysis we can perform. Okay, so introduction. The main thing, like as we are communicating in English language or some common language, we can prefer. Why? Because that is understandable by both parties, right? So here also, whenever we want to write something which is understand by that environment, like Python environment, like computer understand only binary language, similarly in Python we have to follow the syntax which is understandable by the Python environment. So that environment might be different, like Google environment or Conda environment, anything. So we have to follow the syntax. So like here variable and data types. So variable is the concept like where we can store the information. Like you all have your name, your ID, specific ID. Similarly, suppose we want to store any sequence, like some sequence, DNA sequence or RNA sequence. So to store that sequence, we can label a particular name we can assign, and that space is allocated in that memory. Okay, so you can use variables to represent data, sequence data, numerical values, anything. So data type means what exactly data pattern, like suppose integer value you can assign. Float means decimal value. If your data is character value like sequence name, gene name, then there is a string data type. Even boolean data like true false answer is there. So these all variable and data type. Some operations we can perform, like simply arithmetic operations, like addition, subtraction, multiplication, division. These all about numerical data. But if you're handling string data, then like two strings you have, two sequences, you're just doing operations with two string, then there's a concatenation. means joining, or if you just want to find repetitive sequence like this, then these all operations we can perform. Then there is a term data structure. This also we'll learn in detail. So data structure is what? Structure means container. So to store that data, suppose you have multiple sequences or multiple genes, 100 genes. To store that all genes, you need container. In that container, you can store the data. So data structure is like where you store the data. It's like a container. So depending on what kind of data you want to store, like only gene name. So this is a homogeneous data. All are string format, all are characters. If you want to store gene name along with their expression, so some numerical data along with character data. So heterogeneous data. So depending on what kind of data you are storing, a data structure will different or decide, and we have to select data structure to store the data. So for that we should know what exactly the data structure and types. Like types means list is there, tuples, set, then dictionaries are there. So we'll see in detail in a hands-on session. Then control flow. Control flow means like how we can execute the code. So flow of execution, like suppose we can select or just simply consider any pipeline. Okay, so one by one we can execute the steps. So this is a execution flow, control flow. If you want to select something on the basis of result, suppose you want to take a decision, if this is the condition, then switch to this left hand side pipeline. Otherwise, if it is false, then switch to the next line, next code. So this is by using conditional statement. If else, if this is the true, execute the block, otherwise switch to the next block. So code is based on certain condition. Even in control flow we can use loops. Suppose any particular code we want to repeat for multiple elements, so it allows you to repeat the block of code by using iteration process. And for that we can use keywords like for loop, while loop. So we can iterate over the sequence and perform repetitive tasks again and again throughout all elements. Function is the concept like reusable code. Reusable block of code means suppose we want to perform functions like gc content for sequence, so same function we can perform with multiple sequences. No need to write again and again same line of code. So function, like biopython itself is a part library, and inside that library there are multiple functions, specialized function which are for bioinformatic application. Okay, libraries, like different libraries, biopython, matplotlib, these are different libraries associated. Then environment. So environment is what, where we can execute code. And for environment we can use this all syntax, all this terminology. So let's explore what all environments are present to execute python. I think you already work with linux, right? Linux and conda itself, right? Conda, are you aware
Yes,
about
Yes, ma'am.
conda? Yeah.
yes, ma'am. Yeah.
Okay, so Python can run in various environment. Let's first understand what all environments are present and how we can write code in that environment. So output will be same in every environment, just the syntax or the structure is different for each environment. Like, let's explore the environments. Let me open browser. Just a minute. Okay, so first we'll see a conda environment. So here, let me open, or I'll share this link in chat box, so you can also open. Okay, so are you aware about conda term, right? Anaconda or mini conda. So here I am giving link. I've shared this link for mini conda. Okay, so what exactly conda? You can see here the name conda, then Python. There is a random forest. So these are all names are nature inspired names. So Anaconda, if you check in another browser for Anaconda, so this is the Anaconda distribution here. So Anaconda is full-fledged Python distribution, and that includes means not only Python, but there are multiple pre-installed packages are available with comes with Anaconda, and there are libraries which is mostly used for like data science, machine learning, or any scientific computing. So these all libraries, pre-installed libraries, are exist in Anaconda environment. So this is handled by or owned package managers called as a Conda. Conda means which user can easily install, easily update any tool, or just manage the package and their dependencies. So simply we can say Anaconda is designed for user who wants complete or who wants ready to use Python environment for all purpose like data analysis, scientific computing, and many more tasks. Like it's a big package where this mini conda is a lightweight version, we can say lightweight distribution of Python. And this also includes libraries, many libraries, but not much. Like additional package or additional libraries we can install later. Okay, so it comes with conda package manager. The main purpose of this, primary purpose we can say, for this mini conda is provide minimal platform or minimal environment, so we can easily customize or we can expand according to our requirement. It's not necessary to load our system with everything. Okay, as per the requirement we can use. Clear this? So simply we can say like Anaconda is Python distribution with pre-installed packages, where Miniconda is minimal distribution and it comes with Python environment, but let's prefer Miniconda. Okay. Why Miniconda we need to prefer as a bioinformatic or biological student? Because it is lightweight version, so no need to worry about like it comes with a manager like manager conda manager. So whatever specific libraries we need, like important library we need, that is biopython. So that all things we can install as per our requirement. So by using Miniconda we can minimize our storage, even we can avoid unnecessary package or whatever the load on our system. And because of this unnecessary things we don't have here with Miniconda, we can increase the flexibility, we can increase the fast execution. Okay, so let's, what you need to do, just click here installing Miniconda. Anyways we are going to execute our hands-on like practical on cloud environment, but still you should know how to use conda environment for Python. So that's why I'm just showing this. So for that you need to install this Miniconda and just follow the instructions as per like you install any app or any tool. The similarly you can here as per your system, like operating system. If it is Windows you can just download this exe file. For Mac users they can use this .pkg file installer, or for Linux it shell sh file. Okay, so mine is Windows, so I have installed this one exe. Just after downloading this file you just follow the steps and download the Miniconda. Okay, just do this.
Ma'am, for metagenomics, we had used a Miniconda only.
Okay, Miniconda, so you know. Okay, fine. So we can move
Yeah.
forward. So when we install this, after completion of installation, just search here Miniconda. So there are two options, Miniconda PowerShell prompt and Anaconda prompt. So we have to select this app, Anaconda PowerShell prompt. So you can see here we are inside the base environment. Okay, so to use this, those who are not aware about this, for them they can if you want to specify, like here as we used installation in the C drive, so we are getting your C path. So we need to change this by using command, Linux command. This is cd change directory. As in my system I have D drive, so I'm selecting this D drive, and now we are inside this D drive. So here we need to create our own folder where we can perform the task. So for by using mkdir, that is make directory. Make directory is for creating Directory means folder. So here we can create one directory, like here I'm creating Python like this and execute. So directory is generated. Now we want to switch inside that directory to work in that directory. So for switching, again we need to use cd command, change directory and write the name of the directory. Okay. Now we are inside this D directory. So here we can perform the task. Means we are inside this folder, but the base is environment is base. So if you want to change the environment or create the environment, so you can use first a new environment by using command conda. Let's create environment by the name. Suppose we want to perform some basic Python operations. So here I'm creating basic Python by py basic Python. Let's create environment. So it will show message. So you can see here remove existing environment if it is exist. So whenever there is option like y and means yes or no, so the default option is included in the square bracket. So default means when I just press enter it will select the default, but if you want to specify any option then you can write it, like remove existing environment you can write yes. By default it is no, so we can remove existing environment and then we can create new environment, or you can change the name, that also possible. So metadata means all. Now here you can see metadata is related files. So here you can see proceed. So now default option is y. If I just press enter it will execute y and then proceed. So now our environment is ready. To activate that environment we can use this command conda activate. So whatever active command that we can deactivate by just writing conda deactivate. So when I execute this, we are inside this basic Python environment. Now for deactivation, just use conda deactivate. So we are out of this environment. Now this is all about environment. So here, if you want to install Python in Windows, so in Microsoft Store, it will show all the available versions. Like suppose here you can type in store. First we need to go store,
Ma'am,
Microsoft.
sorry, I missed the command which you used for creating the environment. Can you repeat the command? Because it's
Okay,
showing the error.
I'll just paste the command in chat box. Here it is.
Mm,
Conda is manager. So through Conda, we are creating this environment. Okay, so you can write any environment. Here I have written basic Python. Okay, so go to after this. If you want to install Python from store, Microsoft Store, just need to go Microsoft Store. Here you can search for Python. All distributions will be there. Like the one I installed, that you can see with option open, and for others you can see this free and get. So this is the latest one, 3.12, or there is one more I think coming, 3.13. Anyone you can install. Okay, so you just need to open get, so it will install in your system and after that you can open this. So when you click here, okay, let me tell one more thing. So Conda, when we are working with Conda, Conda is a package and environment manager, right? Means when you want to install, like whenever we want to install something for Python, like we need to use pip command, pip command, like pip install. Suppose we want to work with NumPy, pip install NumPy, pip install BioPython, like this through Conda manager. And all the dependencies also installed along with this. There is one more environment, that is Python virtual environment. So this is Python's built-in environment manager, that is called as a V environment, VENV, Python's virtual environment. So there is one more with command prompt we can use. So in your search box, let's type your command prompt, this black window. You can open this. So command prompt or simply terminal. So this directly run the Python from your system terminals or through command prompt. This is very simplest method, but when you want to offer any isolation or any environment, it doesn't support for this all things. Okay, so let me open this command prompt. Here, if you want to check, suppose you want to check for, okay, just let me open this. Yeah, okay. Now here you can search for installed Python version. So Python space hyphen hyphen version. So this is the installed version you can see. And if you just want to execute through Python environment, you can write it here. So this three greater than sign means you are inside the Python prompt through terminal. So here you can search, even you can execute the same command here, version. Okay, here first we need to execute this, install this. Okay, so through Conda, through a Google command prompt, you can enter into Python environment and then we can execute. So now let me tell one more environment. Suppose here you want to install in Conda. For installation, we can use command pip. Let's try to install Jupyter. So we need to write install command first, install, and then name of the environment. Like Jupyter is the environment name. I'll give this command in chat box. This is one environment. You can try this in
Excuse me,
Conda.
ma'am.
Yes.
And actually, we are very new to all this, so if you can just slow down and give us some time to try it
Yeah.
out.
Sure. Yeah, please execute this command as I already installed, so I'm not executing. I have pasted this command in chat box. You can try this command. Pip install Jupyter. So alternatively, you can use this distribution like Anaconda, means it comes with Jupyter Notebook, which is pre-installed. When you launch this Jupyter, it comes with Jupyter Notebook. So whenever we want to write Python code, we can open Jupyter Notebook and then we can execute like in terminal also we can execute or command prompt. It will open as a new window. Okay, so just first install this. After installation, it will take time, few minutes. So after this command, to open Jupyter, we need to type Jupyter and notebook. Okay. So when you execute this command, it will open in a new window. Okay, like this, it will show message and it will open new window. Let me write this command here. You need to type command Jupyter notebook. So Jupyter Notebook is, let me first tell about this. Sideways, you can install this. This is an open source web application. Means here you can create, you can share documents, or sharing means some live codes. Also, you can share visualization, even narrative text you can use here. So in data science, like data analysis or visualization, or simply if you want to share results, we can use this notebook. So it's very great tool for demonstration purpose. Like we can handle collaborative project here. Once you open this, just let me know after finishing this Jupyter. Here, not only Python, but you can use R, you can use Julio. These all things you can use as it is supportive for multiple languages and for data visualization, for data analysis. It's very interactive. Okay. When you open this here, done till here.
No, no, I'm still installing.
Okay, fine. So basically, this Conda environment easily integrate with Jupyter Notebook. So you can create a Jupyter kernel from this Conda environment, and you can also switch environments in Notebook. That also possible. So just check here. Like when you want to write code, just need to go to New. Here you'll get option Python 3. This is a Python kernel. Okay, so it will open like this environment, and here you can write code. There are two types of options, like for code and for comment, like text cell is there. So let me write very simple one, that is 2 plus 3. And when we want to execute this code, either you can use this arrow that run the cell, or you can use shortcut control plus enter. Anything is okay, like this. So here you'll get these options. You can explore these file options. Then for editing purpose, visualization, execution, setting kernel, and from here you can delete the cell. If you not require this cell anymore, you can delete the cell. For adding cell above, for adding cell below, you can use these options. Even there is a shortcut provided like B, capital B, below for B, A for above. Okay.
Ma'am, the Jupyter is installed, but how to open the notebook?
To open the notebook, you just need to write Jupyter space notebook. I have given code syntax in chat box. You can just refer that. In
Ma'am,
here, you just, yeah,
it's
here.
showing Jupyter notebook not found.
So you have not installed it properly. Okay, first installation is required. After installation, you can open that notebook. So for installation, you need command pip install Jupyter.
Yeah, that I've done, and
Huh?
it got installed also.
Okay.
Yeah, after that I wrote Jupyter notebook, the command that you have given.
Okay, so what message it's showing?
Um, it it is showing Jupyter command, Jupyter notebook not found.
So installation is done.
Yes, ma'am.
So can you share your screen, or we'll discuss later? First, we'll complete
Ma'am,
all the.
actually, the command which you wrote in this chat box, it's E is missing in notebook. So maybe she is.
Okay, okay, okay. So that might be the reason. Okay, you just type properly. I think here I made mistake in spelling. Yeah. Okay, like this you can write.
Yeah.
Now execute this command. I hope it works. And when you want to start Jupyter notebook on server, then you can use percent Jupyter space notebook. But right now you just try this in terminal itself. So it will open as a new tab in web browser, which is open in your web browser. And then this is an interface where you can create and you can manage notebooks. Okay.
Okay.
So this is a Jupyter notebook environment. Now let me show one more thing. Okay, let me close this. So there is one more environment that is called as a IPython. Okay. So to activate IPython, same command you have to use pip, because in your environment, in your Conda environment, there is no IPython. So first you need to install IPython like this, pip install IPython. Okay. S- Just try this command. You should know all environments. At least there are many more, but at least few environment you should know how to use. So when you install this IPython, then after installation, you need to open that environment. So to open that environment, you just need to type IPython like this. When I press enter, I'm inside that IPython environment like this. This is the environment. Here you can write command. So in means input. Suppose the same example we are taking here, 2 plus 3. This is our input. When we press enter, OUT means output. So suppose we want to execute any line, suppose like by using print function, we want to execute some sentence. Like here I am executing hello students. So this is the output, hello students. Now I don't want this environment anymore. So we can exit the environment by just using shortcut control plus D. So when I use control D, default option is Y. It's inside the bracket. Do you really want to exit? You can either write Y or you can just press enter. So you are outside this IPython environment. So this is one environment, interactive environment. So IPython basically by the name interactive Python. This is enhanced environment or enhanced interactive environment we can say for Python. And in IPython also there are toolkits are available. Like suppose efficiently we want to work with any data or write any code, like any interactive computational task. So most of the toolkits are available in IPython environment. Like here you check this, already I shown this print statement. Print, now we are outside this IPython. So when I use here print, it already show this hello student message, right? So this is syntax highlighting, auto detection. These all things are there in IPython. Even IPython execute shell commands like directly through this interface. Okay. So this is all about IPython environment. Now just let me tell one more environment, that is pip install spider. So spider is also one environment where you can write Python code. So after installation spider, to open this environment, you just need to type spider. So this is again open as a new tab, new environment. Like here you can see spider version 5. Those who know our environment, I think most of you know, those who present in initial sessions of our programming, they know how we can work in our environment, right? So there is a script editor, console, like the same environment is there for Python. And file is saved with .py. This is the same example, 2 plus 3. If I'll execute here, you'll get output in console. This is input, this is output in spider environment. So this is one environment where you can write Python code. Okay, like this is for execution, save, explore, these all things. Source code, object, numpy. Here you can fetch different libraries in this Spider environment. So Spider is named for I think a specific or no scientific Python development environment, that is a Spider scientific Python development environment. This is also open source integrated development, that is called as a IDE, integrated development environment. Like in R there is a R base and R studio, so R studio is IDE, integrated development environment. Like when we want to perform scientific programming in Python, or it's suited for all kind of tasks like data analysis, scientific computing, even engineering tasks. So this is specifically main purpose is scientific Python development environment. Okay, here also you'll get all options like different tools you can integrate. For analysis you can use numpy, pandas. For visualization you can integrate matplotlib. Even you'll get facility like a syntax highlighting, code completion, and suppose you want to explore any variable to find or modify in real time, that we can perform in Spider environment. Okay, so Jupyter, IPython, Spider. Then there is a Visual Studio, VS Code. Most of you might aware about Visual Studio Code. Visual Studio is again very lightweight code editor, and this also support for all these features like debugging is possible, task running, even version control we can do with Visual Code. And Visual Code integrated with terminal, as well as it's having a Git control. So it's a advanced, or we can say enhanced functionality is there with Visual Code. PyCharm is also one environment. PyCharm is again IDE, means integrated development environment, which is specifically for Python. Okay, like graphical debugging is possible in PyCharm. So these are all different environments, and there are many. Like I'll tell name like Kaggle kernel is there, Thorny is there. I think there is a Snake Maker or Seg Maker notebook is there. Azure notebook is there. These all are Python environments. Now let me show the most useful for us, that is Colab environment, Google Colab, which is executed in cloud. Okay, it's free cloud based service. Okay, so let me open browser. Which one is just open new window. Here you need to type Google Colab, COLAB, or I'll just give link. So Google Colab, whatever your registered account, Google account, on that account you can open this Colab. So in your drive, that notebook will create when you create this account, this Google Colab. So here select the second option, colab.google. Okay, you need to click on this Google Colab. Let me share this link with you. Okay, you can open directly through your registered account, Google account. So what is the difference between Google Colab and other environments? So the main thing is what? Here in Google Colab, it is cloud-based Jupyter Notebook environment. Simply, it runs entirely on cloud, and as it is run on cloud, so no need to install any local machine. Okay, so when you want to access your notebook or any device through internet connection, then if you can see here, there is an option new notebook. Okay, open this. So here you can see Colab is hosted Jupyter Notebook service, which require no setup to use. and free access to computing resources, including GPU and TPU. So, what exactly GPU and TPU? So, GPU means like Google Colab itself provide this two powerful hardware accelerator. GPU means graphic processing unit, and TPU is tensor processing unit. So these are very beneficial when you want to learn any deep learning model or any computationally intensive task. So this GPU and TPU significantly speed up your execution or whatever the code you want to execute, and these are cloud based. Okay, so don't worry about installation, maintenance, version updation. So these all are pre-installed. Most of the libraries which are widely used, they are pre-installed or pre-configured. Okay, the one like which is very specific, like as a bioinformatician, we need BioPython library. So this we need to install externally. This is not installed. So to work with the Google Colab, we need to click on this new notebook option. Here it will open in new window like this, like Jupyter notebook. So through this Google Colab, you can access your other Google services, any API through this notebook. Like if you want to fetch Google Sheets, Google Drive, Google Cloud, and if you just want to work with file which is exist in your system in your Google Drive, like import export. Okay, simply we can perform import export through this Google Colab. So interaction is very easy, and pre-installed libraries are there, means no need to use pip install command. Okay, if we use here pip install any library, suppose I'm taking here example of NumPy, for execution we need to use this cell option, run cell, otherwise you can use control plus enter shortcut. So when we use this, if these are all required libraries, statistically analysis, for this purpose these all libraries are pre-installed in this environment. So when you check this message, just let me, cell interruption, requirement already satisfied, means what, these tools are pre-installed in this Google Colab. You can directly use this, no need to do this installation step. Okay, if you don't want the cell again, you can delete this cell. Like here options are file, edit, view, these many options, and memory. Here you'll get this option is for importing files. So you can import files from your system, even from your drive. Like suppose I want to fetch gene sequence or a FASTA sequence or any Excel file. So upload the session storage. This is session, current working session. So if I click on this, I can upload file from this library, from this folder, any folder we can explore. But if you want to perform with the demo data, then you can use this sample data. Here there are some files, JSON files, CSV files are available. Okay, so you can add multiple code cell to execute code. Let's take same example here, 2 plus 3. This is the code. Let's execute this code. So you'll get the answer, right? Now in this code only execution will perform, you can do. But if you want to write something about that code, you can use this text here. Suppose you can write, this is my first Python's code, like this. So this is not for execution, this text cell is for understanding our information. If you want to take notes for what you are performing, for that you can use this. But the same line, if you write in cell, this cell, like if I execute here and then execute this cell, then it will show error, this is invalid syntax, because this is not for execution. So if you want to hide this from execution, you can use comment like this. Now it will execute. So comment means not for execution, this is just for our understanding. And here there is no problem of this doing comment and all these things. Okay, So this collab notebook, we can easily share with others. We can export. If you want to save this, we can download this, save, rename, download. For download, there are options like extension. Either you can use ipynb.ip. So the script will download. You can also reuse this or fetch this script in new environment for execution purpose. Okay, so IPYNB, basically this is used for collaboration, or if you want to share your work with a broader audience, then we can use this thing. Okay, so this is all about Python introduction and installation, different environments. So from next session onwards, we will work in this collab environment. So it is easily shareable. You can store, you can fetch files, whatever we are performing in live session. Okay, please practice for other environment as well, just to know how to work with this. You should know. So that's it for today.